Hello and welcome to the lecture on integration and automation. I am happy to have you in this lecture. The objective of this lecture is to help you understand integration and automation in detail. So without wasting other moment, let's dive deep into the subject. In this slide, we are looking at a very simple but very important idea in the world of integration, which means different systems need to exchange information with each other. On the left hand side, we have system A. On the right hand side, we have system B. Both systems can be anything, an ERP, a CRM, a database, a cloud application, or even a file server. Each system supports a different way of sending or receiving information. For example, they may work with file system, database, SOAP web service, REST API, applications like Salesforce, Cloud FTP, SFTP servers, and many more other ways to send or receive the information to that system. Now the challenge in modern enterprise is this. These systems do not speak the same language and do not understand each other's data format. However, the business still needs them to share the information. This is where the integration comes in, right? The big yellow arrow in the middle represents the exchange of the information between system A and system B. So this could be something like sending customer data, pushing orders detail, transferring files, updating the inventory, syncing the employee records, or any business transaction. So in simple terms, this slide shows the core purpose of integration and automation, which means to connect two or more systems and make them talk to each other, which ensures smooth, secure, and reliable flow of information across the organization. This is exactly the problem that modern integration platforms like Boomi are designed to solve. In this slide, we are looking at a very important concept in the integration, which is called as connectors. To understand connectors, let's first look at the problem we are trying to solve. On the left hand side, we have system A, right hand side, we have system B. To understand connectors, let's first look at the problem we are trying to solve. Each system speaks its own technical language. For example, some systems expose SOAP web service, some provide REST APIs, some store and exchange data using files, some communicate using databases, some use cloud applications like Salesforce, some rely on FTP or SFTP servers. The challenge in integration is not just connecting the systems physically, the real challenge is how to communicate with them in their own native language. This is exactly where connectors come in. A connector is a pre-built specialized component inside an integration platform that knows how to connect to a specific system, how to authenticate using that system's method, how to send and receive data in the format that system expects, how to understand that system's protocols, standards, and rules. So think of connector as translators or adapters. If system A speaks SOAP, then system B speaks REST. The connector ensures both side communication smoothly without you manually writing low-level code or learning each system's protocol. So connector solves these three big problems. First is the connectivity. They handle the actual connection setup like URLs, ports, credentials, token, certificate, and so on. It helps for the communication. They know the system communication style. For example, what headers are needed, how requests should be structured, how responses are returned. It also handles the complexity. They simplify interaction with complex systems. Instead of writing 100 lines of code, you simply configure the connector. So the connector brings this bridge between system A and system B. You only define what data you want to move, not how the protocol works internally. Right? This is why the connectors are one of the most powerful features in any integration platform. They remove this technical barrier, eliminate manual coding, and allows you to integrate modern legacy, even cloud or on-premise application in a simple and a standard way. By using the connectors, integration becomes faster, easier, and less error-prone, enabling organizations to build automated workflows and connected processes with minimal effort. In this slide, we are looking at the heart of the integration solution, which is the process flow. So each system may store data differently, expose data differently, or expect data in a specific format. To make the system work together, we need a clear step-by-step workflow that tells the integration platform what to do, when to do, and how to do it. This workflow is called the process flow. A process flow defines the business logic and the sequence of actions required to complete an integration task. Think it as a blueprint or a recipe that the integration engine follows. In the example shown in the slide, we have a real-world integration scenario. First is the fetch data from a file server. The process starts by picking up a file from a specific location. Then you look up an additional information from a database. The incoming file may not contain all the details, so the process retrieves extra data from the database. Then you send data to a Salesforce. So after preparing and enriching the data, the process pushes it to the Salesforce system. And if any error occurs, upload an error message to the Cloud FTP server. The process also includes error handling, any failures uncaptured and stored on a Cloud FTP server for review. A process flow is useful because it helps us automate these activities without manual intervention. So you don't need a person to check folders, perform database queries, or log in into Salesforce. Once the process is designed, the platform executes it automatically, consistently, and reliably. So the role of the process flow is to define the logic of how data should move from one system to another. Also to orchestrate multiple actions such as reading, transforming, writing, or validating the data. Also to apply rules like transformations and lookup. Also to handle success and failure paths. Ensure automation so tasks run without the human effort. Also to connect different systems into one unified workflow. So in simple terms, a process flow is the engine that drives the integration, right? It coordinates all the steps required to move the data, convert formats, apply the business rules, and ensure that the right information reaches the right system at the right time. So behind every smooth integration you see in an organization, whether syncing customers, updating orders, sending invoice, or transferring files, there is always a well-designed process flow working in the background. In this slide, we are focusing on one of the most critical activities in any integration project, which is data transformation. So let's say you have system A and system B. Both systems may store data in different format, structures, and layouts. For example, system A may send JSON, while system B may expect XML. So one system may use a flat file while the other works with database tables. Even when two systems are supposed to exchange the same business information like customer data, orders, invoice, or inventory, they often represent that information entirely different formats. So this mismatch is the main reason why data transformation becomes very essential. The data transformation basically is the process of converting data from format of the source system into the format that of the target system that understands. So this slide shows some common examples, which is JSON to XML, flat file to XML, XML to database format, and XML to XML when structure differs. So each system has its own way of structuring fields, naming the elements, representing the relationships. So without transforming the data, the receiving system simply cannot read or process the information correctly. So you see, the data transformation plays a major role in integration by ensuring compatibility between the systems. It makes sure the structure, format, and the layout matches what the receiving system expects. And also by handling structural differences, one system may send 5 fields, another may need 20 fields. So transformation allows to reconstruct and enrich the data. Also by standardizing and normalizing the data, it allows to clean, reformat, and standardize data before sending it to the another application. Also it helps us to enrich the data. During transformation, we may add extra information. We do some lookup values from other system or apply some business rules. We can also do automating the complex mappings. Transformation automate the process of aligning mismatched schemas and remove all those manual works. So you see, the data transformation is at the center of the integration, right? Because it acts as a bridge, not between the system, but between how system data understand it. Even if two applications are connected, they cannot fully communicate unless their data formats are aligned. So transformation ensures that the right data in the right format reaches the right system every single time. So in simple terms, without data transformation, integration would fail because systems speak different data languages. So transformation translate and read structures that information so both sides can communicate smoothly and accurately. So in this slide, we are looking at another key building block of integration, which is nothing but the scheduling. So we have system A and system B. So both systems may contain different type of data like files, database, SOAP, REST, Cloud FTP servers. To move or sync this data between systems, we need to decide when the integration should run. This is where scheduling comes into the picture. The scheduling is a mechanism that tells the integration platform when to execute a specific process flow. In other words, scheduling defines the timing, the frequency, and the trigger for an integration to start running automatically. And this slide shows common scheduling patterns such as daily, hourly, specific time of the day, even every 5 minutes. So these options allow organization to automate their business process without manual intervention. And also scheduling plays a very important role in integration for several reasons. First is automating the recurring task. Let's say instead of someone manually running the integration, the system execute by its own at different intervals. For example, the load sales data every morning at 6 a.m. or send inventory update every 30 minutes. When you have such kind of scheduling scenarios, you can do it via the integration tool. Also, it ensures timely data movement. Different business process run at different rhythms, right? So scheduling ensures that integrations are aligned to those rhythms, so data is always fresh and up to date. Next is to reduce human dependency. By automating the trigger, organization removes the need for someone to remember to run a job. This improves accuracy and reduce the operational workload. It also supports high volume and low latency scenarios. Some integrations run weekly, while others may need to run every few minutes. So schedule basically handle both extremes very easily. There also could be requirement of orchestrates the chain reactions. Let's say certain task must run only after previous task finish. So scheduling helps maintain that order and ensure proper execution. In simple terms, scheduling is what keeps integration running continuously and consistently. So without scheduling, data would not move automatically between the systems. So you would have connections, you would have transformation, you would have process flows, but nothing start on its own. So scheduling is basically the heart of the integration, ensuring that every process run at the right time, at the right frequency, and in the right sequence to keep the business connected and automated. In this slide, we are looking at very important part of every integration design, that is the error handling. So when we build an integration between two systems, everything may work perfectly most of the time. But in real world, systems are not always predictable, right? Connection fails, API return errors, data arrives in the wrong format, or a target system may be temporarily unavailable. This is where error handling becomes very essential. So an error handling defines how an integration should behave when something goes wrong. So instead of stopping the entire process or silently failing, the integration platform must intelligently detect the issue and takes the appropriate next step. The slide highlights the common error handling activities. First is the automatically retry failed connections. So sometimes failures are temporary, for example, network glitches, cloud API timeout, system unavailability for a few seconds. Automatically retry basically ensures that integration try again before giving up. So this dramatically improves stability and reduce manual interventions. Then you have alerts and notification. If something fails, the right people must know immediately. So error handling can trigger email alert, system notification, dashboard warnings, message to the operational teams. This ensures that issues are resolved quickly before they impact the business. Next is logging the error. So every failure must be captured and logged. This helps team to analyze what went wrong, review failure patterns, perform root cause analysis, improve the future integrations. Logs can also act as a proof that the integration system is monitored and supportable. So error handling plays a very major role in integration by ensuring the reliability. The integration keeps running even if temporary errors occur. It helps to reduce business disruption. Issues are detected early and communicated immediately. It helps improving supportability. It clears up the error logs, help us quick fix the problems. It helps protecting the data integrity. So failures are detected before incorrect data is processed. It also helps in automating the recovery. No need for manual restarts or reruns. So in simple terms, error handling makes sure your integration doesn't collapse when something unexpected happens. It keeps the system stable, predictable, and supportable. So without proper handling, even a small issue can cause a major data loss, duplicate records, failed transaction, or business downtime. So error handling is not an optional feature. It is the core pillar of any strong integration design. In this slide, we are looking at a very key part of integration, that is the deployment. When we build an integration process in Boomi, designing the flow is one step, To actually run that integration in the real world, we need to deploy it to the runtime environment. So deployment determines where and how your integration will execute. So in Boomi, you can deploy to cloud runtime, on-premise runtime, or hybrid runtime, a combination of both. So each deployment model has a specific purpose and a use case. For cloud deployment, the integration runs in Boomi's cloud runtime environment. This is ideal when both systems are cloud-based, and no local network access is needed. Business, this used for quick setup, scalability, and lower maintenance. The on-prem deployment, in this model, your integration runs inside your local network on your own server. This is required when you access to internal database, access to on-premise application, high security and restricted systems not exposed to the internet. Boomi installs a lightweight runtime on your server that execute the integration locally. Then you have the hybrid deployment. So hybrid deployments combine the strength of both cloud and on-prem. For example, you want to fetch data from an internal database using an on-prem runtime and send data to a cloud system using a cloud API. And also to handle security and performance by distributing the work. So this gives the maximum flexibility for modern enterprise environments where the applications are distributed among the on-premise and the cloud applications. So you see, deployment plays a very critical role in Boomi by ensuring that the integration runs in the correct environment. If your source system is inside your private network, how it improves the performance? It improves the performance by running the integration near the data source, which reduces latency and improves the speed. It also helps supporting security and compliance. So sensitive data can remain inside the organization without sending it over the internet. Next, it also provides flexibility. Boomi allows you to choose what works best for your architecture, like cloud, on-prem, or a combination also. So it provides all these flexibility options for deployment. Then allowing the seamless execution. Once deployed, the integration can run automatically based on schedules or triggers. So in simple terms, deployment is the final step that moves your design integration process into a real runtime environment where it can actually execute and exchange data between the systems. So without deployment, an integration is just a design. It cannot run and cannot connect and cannot automate anything. The deployment is what brings your integration to life. In this slide, we are looking one of the biggest reason organization invest in integration platform, which is nothing but the automation. So when you build an integration between the systems, the real goal is not just to move the data once. The real goal is to ensure that the entire process runs automatically without manual effort, repeatedly, reliably, and consistently. This is where automation becomes essential. That's why automation is the capability to make the entire integration run on its own from start to finish based on the scheduled or event trigger mechanism. This slide highlights typical automated actions like start at a scheduled time, connect to the source system, fetch or receive the data, convert or transform the data, send the message to the target system, or complete the process or log any errors or exception. So all this task basically happens automatically without anyone clicking a button or manually triggering the workflow. So automation basically plays a major role in integration by enabling all these features like hand-free operations, continuous data movement, end-to-end orchestrations, reliability and stability, scalability, operational efficiency, wherein the team don't need to monitor every step manually. This automation eliminates repetitive tasks and improves the productivity. So in simple terms, automation is what makes integration truly powerful. You're not just moving the data, you're automating an entire business process. Without automation, integration will still require manual involvement, which defeats the purpose of modern connectivity systems. So automation ensures that integration runs smoothly, regularly, and complete on their own. It is the final step that ties all the building blocks like connectors, process flow, transformation, scheduling, deployment, and error handling into a single, seamless, and self-running solution. In this slide, I want you to remember all these keywords. You have to know all these keywords to know what is integration and automation in Boomi. When someone talk about any of this keyword, you should be able to ready to at least explain it what it means. Okay, so let's go through these keywords. I'll give you some examples. I'll give you some definitions for help you to understand what it means. First is the pre-built connectors, which is called as plug and play connectivity. So Boomi provides hundreds of pre-built connectors for popular scenarios like enterprise application, which is NetSuite, SAP, Salesforce, Workday, ServiceNow, Oracle, all this application, a connector is given by Boomi for us to readily use it. It also gives connectors for pre-built connectors for databases like MySQL, SQL Server, Oracle DB, PostgreSQL, etc. It also supports protocols and technologies like HTTP, REST, SOAP, OData, FTP, SFTP, SMTP, JMS, etc. It also provides connectors for cloud storage platform, Amazon S3, Azure Blob, Google Cloud Storage. These connectors type include application connectors, technology connectors, database connectors, events-based trigger, which like file watcher, listener, but not event stream, but listener. It has custom connectors via connector SDK. What is the purpose? You don't write the code to talk to application. Boomi handles the interaction for you. It gives you the pre-built connector. You just have to drag, drop and readily use it. Next is the low code process builder, which is the integration designer. So Boomi's visual designer allow you to create integration using the shapes, right? So there is a start shape, there is a connector, there is a data mapping, there are business rules, decisions, if and logic, branching, routing, exception handling. As a designer, you only have to drag and drop and start configuring the shapes. So it requires minimal coding, it encourages reuses, is fast to learn for beginners and make integration clear and documented visually. Next is the data mapping and transformation. Boomi includes a powerful map editor to translate data between the formats like JSON, XML, CSV, flat file, database tables, application payloads. It has capabilities include field-to-field mapping. It has functions which can do mathematical, string, date function. You can do custom functions in Groovy and JavaScript. Then you have lookups. Then you have cross-referring tables. You have normalization and enrichment. And also, as I mentioned, you have custom scripting as well. What is the purpose? When two systems speak different language, Boomi translate the data so both systems can understand it. Next is orchestration and the process flow control. Beyond simply data movement, Boomi allows automation of multi-step business logic inside an integration. You can orchestrate sequential processing, parallel processing, conditional routing, exceptional branches, sub-process calls, you can do looping, you can do batch handling. So this turns Boomi from just a connector into a complete orchestration engine, enabling automated business flows which runs end to end. An example could be, you read customer data from CRM, validate the fields, transform to ERP compliant format, create a customer record in ERP, log the transaction, notify someone if something fails, all automation inside one integration. Then you have scheduling and process automation. So Boomi supports multiple ways to automate integration, like automation triggers. File arrives in a folder, message is received, database lookup, polling a source system, success failure for the process. This is an automation triggers, right? Based on the triggers, you can automate your process. Then you have scheduling. You can run process for every 5 minutes, hourly, daily, weekly. You can schedule like a cron job. Then you have real-time invocations, which means process can start via the REST or SOAP calls, not API management, just the invocation of a REST or a SOAP call. Then you have applications or systems can call Boomi directly to trigger a process. What is the purpose? You can automate data synchronization, system update, business process without the manual involvement. So Boomi provides try-catch like exception shapes, document level error routing, retry mechanism, logging, alerts and notification, tracking of failed documents, reprocessing capabilities. This ensures processes remain stable even when API limits are hit, systems are temporarily down, and data quality issues occur. Next is deployment flexibility, which is the runtime execution. So integration are executed on Boomi runtime, previously known as Atom, which is single node runtime, Molecule cluster runtime for load balancing, and Cloud, which is managed by Boomi, then private cloud or hybrid. Once you have an integration package, you can run the same integration package in any runtime without rewriting the code. That's the benefit get by Boomi's architecture. So this ensures flexibility, controlled data movement, compliance with on-premise systems, high availability as well. Next is the reusability and the shared component. So Boomi encourages reuses through shared connections, shared maps, shared functions, shared subprocesses, shared business rules, shared profiles, let's say JSON or XML schemas. This reduces the development time and ensures consistency across the project. So what is Boomi automation? So in context of integration and automation capability, Automation means automatically triggering, executing, managing, and orchestrating the integration process without the manual intervention. And what it includes scheduled automation, event trigger automation, error and exception automation, multi-step orchestration, data transformation automation, end-to-end system to system process automation. So most automations in Boomi happens inside the integration builder. So we have talked about integration, we have also talked about automation, and these are the keywords that you have to remember. If you're not clear of any of the topic, please go through this video again. You have to know all these things that I've just discussed in the area of integration and automation. Right? I hope you're now familiar with integration and automation. Well, that's the end of the session, so let's wrap it up. By now I should be able to explain integration and automation in your own terms. Thank you so much for your attention and listening till the end. I wish you a fantastic day. Bye and take care.